Okay, now it's recording. Okay, so for the rational root theorem, the first step is to list all factors of the constant. What's a constant term? Does anyone know? Silver? Good. So like 7, right? It's a term that does not have the variable. -4. Those would be constants. If we say -4x, it's no longer a constant. Okay? So we're going to list all the factors from the polynomial's constant. Second step is to list all factors of the leading coefficient. Okay? List all factors of the leading coefficient. The leading coefficient is the term that has the highest exponent, right? If our highest exponent is x to the 5th, it's whatever number is in front of x to the 5th. Such as 2x to the 5th, it would be 2. Okay, that would be the leading coefficient. Okay, after we have our list of factors, we're then going to combine these and write list all possible rational roots by combining these as a fraction. A rational is anything that can be written as a fraction. So our numerator in the fraction is going to be the constant factors. The denominator of the fraction will be the leading coefficient factors. Okay. After we have all possible roots, we have to find which ones are actually the roots. And so we find which ones are actually the roots by plugging them in. We're going to then plug in all possible rational roots into the polynomial. And we'll know that it's actually a root if it equals what number? Oh, I heard it right here. What is it? 0. Good. Because if we are on the x-axis, then the height is 0. So we'll know it's a rational root. If when we plug in the x, we get 0. Okay, that's a lot of steps. Now we're going to actually do a problem and apply these steps so you understand what they mean. Okay, we're just going to do 2 problems today, and we're actually on a good track. We might have time to start your homework together. Okay, example 1. Our first polynomial is 2x cubed. Oops, that paper fell out. 2x cubed minus x squared plus 2x plus 5 equals 0. So it's a polynomial equation because it has an equal sign, makes an equation. And we want to know, when does it equal 0? Right? Because if it equals 0, then it's a root, which means that's a point on the graph that crosses the x-axis. Okay, read up at the top of your notes. What's the first step? Factors of the constant. Show me with your fingers. What's the constant? Good. The constant is 5. So let's do, because it doesn't have an x, right? Factors of 5. Okay, you might only be thinking of 2, but I can actually think of 4 factors of 5. Factors are numbers that divide evenly into 5. 1 and 5. I can think of 2 more. Nope. Factors are smaller or equal to. Negative 1 and negative 5, right? Plus and minus 1, plus and minus 5. So we have to be cautious and make sure we're keeping track of the negatives as well. After we have the factors of 5, then step 2 is find the factors of what? The leading coefficient. Okay, show me, what's the leading coefficient? What's the leading coefficient? Is it 5? Is it 2? Is it negative 1? Good, it's 2. The leading coefficient's right here. Okay, so now we're going to list all factors of 2. Okay, Styles, can you give me the factors of 2? Okay, I think there's 2 other ones though. There you go, plus and minus 1, plus and minus 2. Step 3 says we're going to now write all rational possibilities for roots by making it a fraction where the factors of 5 are in the numerator and the factors of 2 are in the denominator. So let's list all possible roots. Okay, so we have 2 possible denominators. I'm going to start with a 1 first. What is 1 divided by 1? 1. Okay? What is negative 1 divided by negative 1? 1. What if one of them was positive and one of them was negative? Then we get negative 1. So we have 2 possible roots here, plus and minus 1. Now using the 1 as the denominator again, we're going to move over to the 5. What is 5 divided by 1? 5. What is negative 5 divided by negative 1? 5. But what if one of them is positive and the other one's negative? Negative 5. So we're going to have plus and minus 5. Now we've used this one twice, so it's been used as many times as we could use it. Now we're going to scoot over to the denominator of 2. What's 1 divided by 2? 1/2, right? Negative 1 divided by negative 2? 1/2. And if one's positive and one's negative, so we have plus and minus 1/2 as options. Okay, now 5 divided by 2. What's 5 divided by 2? 2.5 or 5/2, right? And it will follow the same pattern. We'll have a positive and negative. So we actually have 8 potential roots. And we're going to find out and see which ones are actual real roots where the graph would cross the x-axis. Okay, now there's, because it's an x cubed, it tells us there are 3 roots. But sometimes the roots are real numbers and sometimes they're imaginary numbers. So we're going to find out how many real roots out of these 8 exist. Otherwise, the other ones are going to be imaginary. Okay, so we need to plug in, because the last step was plug them in. Sometimes we do a table vertically, sometimes we do it horizontally. Because of space, I'm going to choose to do it horizontally. We need to plug in all 8. We'll plug in 1, negative 1, 5, negative 5, 1/2, negative 1/2, 5/2, and negative 5/2. When I say plug in, what are we actually plugging into? The equation. Wherever there is an x, I'm going to scroll up a little bit. This equation at the very top, next to example 1, wherever there's an x, so it says 2 and then an x, we're going to put parentheses, cubed, minus, there's an x, so we put parentheses, squared, plus 2 parentheses plus 5. And we want to know if it equals 0. Okay, so I'm going to give this side of the room the positives, this side of the room the negatives. Okay? And actually, for sake of time, let's do, I'm going to assign you actually based off of rows. So this first row, do positive 1. Okay? That's U3, and the second row over there, do positive 5, plug it in. The third row, do positive 1/2, or 0.5. Okay, you guys are on the negatives. So first row here, do negative 5. or negative 1, sorry. Second row, do negative 5. Third row, do negative 0.5. And the last row over there, do negative 2.5. And I'll do the extra one we missed. So we missed one of the positives, which was 5/2. Turns out to be 35. So you just plug in. Whatever your number is, you put it in this parenthesis. If you haven't signed your calculator use agreement form, you get that signed. So you have to work it out by hand, which always are possible to do by hand. Anyone want an extra calculator use agreement form?
These are being batteries, right?
Yep, four AAA batteries. Of course, new, that are a recognizable brand. Okay, I'll give you about 60 more seconds to get your solution. So the first group should have done this. They take their 1, and wherever there's parentheses, they plug in 1. Okay, first group, what did you get? 8. Good. How about the negative 1 group? You guys just plug in negative 1. What did you guys get? Okay, we're waiting on you guys. What about the positive 5 group? Do you have yours? 240 is correct. Negative 5 group? Negative 280 is correct. The 1/2, positive 1/2 group over here, what did you guys get? 6. Okay, negative 1/2 group? Yeah, but you're not that group. It's the third row. It's the third row. Yours is a fraction or a decimal. Okay, what about that last group, negative 5/2 group? It's a decimal as well.
Negative 195.
Yeah, that's not right. It's negative 75/2, which is, let's see, what's half of 74? 35, 37.5, negative 37.5, I think. Okay, we still have 2 missing. Help us figure them out, guys. We need to know negative 1 and negative 1/2. It's not actually. Try it again. Help them out. Because so far we haven't found any of them to equal 0. One of those that's missing is our answer. So we have to know which one it is. Help them out. Plug in negative 1, like it's written here on the board. And someone else plug in negative 0.5. Raise your hand when you have the answer. Which one did you do? Okay, what'd you get? 0! Oh, we found it. What about this one? Yeah, it's not 0. It's 7/2 or 3.5. Okay, so only one of these was our solution right here. So of all the possible roots, only one of the roots is actually going to be real, which means the other 2 are going to be imaginary, which we don't have to find today. Okay, so for our answer, whoops. Just try to make that longer. For our answer, we write the only rational root is negative 1. The only rational root is negative 1. Am I supposed to give this to the student? I don't have her right now. I had her yesterday. Okay, let's try another one. See, this is why I'm only giving you 3 problems for homework. On the second one, after we find one root, I'm going to show you a shortcut when there are more than one root available. Okay, So example 2 is 2x cubed plus x squared minus 7x minus 6 equals 0. 2x cubed plus x squared minus 7x minus 6 equals 0. So step 1 is to list the factors of which one? Of negative 6, the constant. Okay? Write all the factors and then turn to your neighbor and tell them what factors you wrote down. There's 8 of them. Okay, turn to your neighbor and tell them what factors you found. These are numbers that are smaller or equal to 6 that divide evenly. Okay, Lisa, what are some factors? Plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. So it only looks like there's 4, but because of the positive and the negative, it's actually 8. Okay, then we write factors of which number? 2, which we know are plus and minus 1 and plus and minus 2. Then we're going to divide them and write all possibilities. Okay, using first, let's use the 1 as the denominator first. What is 1 divided by 1? 1. And negative 1 divided by negative 1? 1. And what if 1's positive and 1's negative? Okay, so pretty much we'll just know on all these we're going to get plus and minus, right? Okay, what's 2 divided by 1? 2. So we're going to do plus and minus 2. Okay, what's 3 divided by 1? 3 divided by 1?
3 divided by 1.
Uh-huh. How many 1s are there in 3? 3. There you go. 3 divided by 1 is 3. So we'll do plus and minus 3 because we know there will be a negative option. And 6 divided by 1 is plus and minus 6, right? Okay, now we have to use 2 as the denominator. Okay, what is 1 divided by 2? 1/2. So we'll write plus and minus 1/2. What is 2 divided by 2? 1, but we've already written that, so we don't write it again. Okay, what's 3 divided by 2? 3/2 or 1.5. So plus and minus 3/2 or 1.5. And the last one, 6 divided by 2? 6/2, which is 3, and we already have 3, so we don't have to write it. Oh. Okay. Thank you. Okay, so of all these possibilities, we have to find which ones would give us a value of 0 when we plug them in. So, once we find the first one, I'm going to show you a shortcut to find all the rest. So, we'll plug in our x and get p of x. P stands for a polynomial, the polynomial function. So we have to plug in 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6, 1/2, which it might be easier to plug in 0.5, negative 0.5, 1.5, and negative 1.5. Barely fit that on. But the good news is we just have to find the first one. And I'm going to show you a way to find out the rest of the factors quicker. Okay, so let's break it up. This half, plug in 1. This half, plug in negative 1. He's not here. I've never actually met that student. Okay, so here is our polynomial that we're plugging into. 2, wherever there's an x, what do I put? Parentheses, cubed, plus parentheses squared, minus 7, parentheses, minus 6. And we want to know when it equals 0. Okay, so this side of the room, you guys do positive 1. This side of the room, you guys do negative 1. And get the value, please. You guys are doing negative 1. When you have your value, shoot up your hand. Okay, so then what does 1 give us? Negative 10. Okay, so that's not a root, right? Okay, negative 1, yeah? 0. Ding, ding, ding. Guess what? Since we found the 0, we don't have to do the rest. Okay, so now what we're going to do, if this is an x cubed, we know one of the roots, so it's like long division on your last test. We can factor out the root by dividing it away. So if our 0 is negative 1, that works. Oops. There you go. We're going to do what's called synthetic division. Sorry, I went brain dead for a sec. Synthetic division. So I'm going to write that root we found, negative 1, and we're going to divide it out and see what's left. So, to see what's left, we need to just instead of doing long division with all the x's, all we're going to do is take the coefficients. So we're going to take 2, 1, what's the next part? Negative 7 and then negative 6. So 2, 1, negative 7, negative 6. 2, leave a space. 1, leave a space. Negative 7 and negative 6. We're going to do synthetic division. You can do long division as well, like you did on your test, but synthetic division will probably be a little faster. So, in the columns, you add up the columns. There's nothing here, so 2 plus nothing is 2. Then what you do is you times negative 1 times 2. Anything down here we times to the box. So what's negative 1 times 2? Negative 2. And then you add up the column. 1 minus 2 is negative 1. And then we always take this number and times it by the box. Negative 1 times negative 1 is 1. Then add it up. Macon, what does this add to? Good. Negative 6. Then Macon, what do I do with this negative 6? Times to negative 1. So negative 1 times negative 6 is positive 6. And then we add them up and we get 0. So this tells us we have a remainder of 0. Negative 6 is our constant. Negative 1 is the first x. And 2 is the x squared. Okay. Now, this polynomial right here, do we know how to factor those to find the zeros or the roots or the solutions? Yeah, how do we factor this? What? Okay, and then do what? It's a trinomial. How do we factor trinomials? The x box. Okay, so we've done this before. You do have the option, if you don't like doing the synthetic division, you could just go through and fill out the chart and find the ones that equal 0, right? So you could, if you like to do just the chart, you could keep going with the chart. Otherwise, you could do it this way. So, in the top left, what do we put in the top left? 2x squared. You guys did this last year, and you're doing it again this year. Remember, we've done this before. And then the negative 6 comes down here. You times those together. 2 times negative 6, which is negative 12. So we're looking for two numbers that multiply to negative 12 and add to the middle term. It's always the middle. The middle term is negative 1. Okay? What are two numbers that multiply to negative 12 and add to negative 1? 4 and 3, and to add to negative 1, which one has to be negative? Negative 4 and positive 3. So those are your x's, negative 4x, positive 3x. Okay, Selena, after we fill in this box, what do we do with all those numbers? To find the zeros, or the factors first. We don't multiply, we look at the row and find a greatest common factor. So in common these two have x, in common these two have negative 2. In common these two have 2x, check the signs, it works. In common these two have 3. So, we found factors, x minus 2 and 2x plus 3, but how do we find them as zeros? Set them equal to 0. So this one's x equals positive 2. This one we have to do a little work to set it equal to 0. Subtract 3. Oh, shoot. We get x equals negative 3 halves. And don't forget, at the very beginning, you had x equals negative 1. Okay, you have, sit down. You have 3 problems for homework. Those 3 problems are, right here on the board, but it needs to be done on a separate piece of paper because these problems take a lot of space. Page 287, numbers 11 through 13. Word of warning, if you don't come with your 3 problems of homework done, you're going to line up and call your parents and tell them you didn't do your homework. It's only 3 problems.